In section 5.5, we're going to be looking at graphing linear inequalities, nonlinear inequalities, and systems of both linear and nonlinear inequalities. So the graphing portion is very similar to what we've already been doing. When we graph a line, when we graph any form of a parabola, there are certain characteristics we need to graph them. The things that change, or the things that get added to the process when we're looking at inequalities, are really two things. The first question is what kind of line you're going to draw, and the second question is regarding shading. So in regards to the type of line you're going to draw, whether it is, again, a line, whether it's a parabola, the type of line, whether it is solid or dashed, is the question. And it is as simple as you'll draw a solid line, I'll call it what you're familiar with drawing, a line, if the original inequality contains the or equal to symbol, regardless of whether it's less than or greater than. The or equal to is essentially saying you want the points on the line. Because think about an actual equation of a line as an equation. It's where something equals something, and that gives you the y and x values that are on the line. So the or equal to basically includes the equality option. However, if we're working with an inequality that only has a less than or a greater than symbol and no or equal to, we don't want to include the points on that line, so we'll use a dashed or dotted line. So right where that line would have been, but again, not a solid line, representing that those specific points aren't part of our answer. Now, the other thing we need is we need an entire area to be shaded, because these greater than or less thans are less restrictive than an equation. Meaning when you draw an equation of a line, you want the points right on that line. When you refer to having an inequality of greater than or less than, then you're looking at a whole extra group of points that satisfy that. What it boils down to pretty straightforward is if you've got a y value compared to other things, the greater than is going to be above and the less than is going to be below. So y is greater than something, shading above a line, y is less than something, shading below it. However, the more kind of direct approach, it can sometimes involve a little bit of work, but it's always going to get you the right answer, is using what we call a test point. So once you've got your picture drawn, you can simply pick one side or the other of whatever graph you've drawn and pick any point in that what's called a half plane. Basically, this figure, this line, breaks our entire XY plane into this side of the line and this side of the line. So you pick a point on either side. Normally, I'm going to pick 0, 0, unless it's on the line. You pick it, you plug it into the inequality, and you see whether it makes the inequality true or not. Right? If it does, if a true statement results, then we shade that particular half of the plane. If we plug it in and it's wrong, if it doesn't create a true statement, then we know we're going to shade the other half, the other side of the figure. So that's really what it boils down to. Down here in the chart, it describes two specific situations for a vertical and horizontal line. Again, you can pick a test point, or you can just kind of understand what the greater than and less than imply. So for a vertical line, a line straight up and down, it's going to be an equation of x. Well, as soon as you read an inequality of x is greater than a number, right? X is greater than, just say 3. You're going to have a vertical line at 3. Well, then which side of 3 are numbers greater than 3? To its right. So we know for vertical lines, greater than's to the right and less than's to the left. Just like we know for horizontal lines, y is greater than would be shaded above, y is less than would be shaded below. So those are more straightforward ones, but again, you can always rely on a test point if you are at all concerned about shading the correct region. So let's look at this first one. Got 2x minus 3y is greater than or equal to 6. So let's get that into graphing form. I'm going to subtract the 2x, divide by the negative 3. Now, when I divide by a negative 3, don't forget this rule of inequalities. Anytime you multiply or divide both sides of an inequality by a negative, that sign has to flip, right? Turn it around, giving us a positive 2/3 x minus 2. Okay? Now, with that, we can graph that. We've got a y-intercept of negative 2, and then our slope is 2/3. So if I'm interpreting that as a rise and run, that's going to be up 2 and right 3. So from this point, if I go up 2, right 3, up 2, right 3, or down to left 3 would be another way to get there. There's a couple points. Now, to draw this line, we got some points. To draw the line, first and foremost, we want to point out this is an or equal to inequality. So that is why we're going to draw a solid line. If you've got that or equal to, then you want to include the points on that line. Now, like I said, there is a less than, which we can generally say if you're comparing y to something and it's a less than, you want to shade below, but let's prove it. Notice here's my test point. I'm going to use 0, 0. It's not on the line. So testing 0, 0. You can test it here. You can test it here, wherever you want to, officially, whichever form of the inequality you want. So I'm going to plug in the zeros there, which gives me 0 minus 0. So I'm getting 0. Oops. Meaning 0 is greater than or equal to 6. And notice that is false, right? Since that is false, this point 0, 0 here is not in the shaded region, right? We do not want to shade any of this because 0, 0 did not work in that inequality. Also, that tells us that if this side isn't the right side, the right area, then this side is. So everything above that line and including it, right? Every point in that region would be a solution to our original inequality. Okay, so next one, y is greater than negative 2/3 x. Already in graphing form for us, if we think of that as just a plus 0, so it goes through the point, the y-intercept of 0, and has a rise of run. I'm going to go ahead and interpret that as a negative 2 over positive 3, so a down 2 and right 3 to graph this guy. Down 2, right 3, or I could also go up 2, left 3. Either way, there's some points. However, notice this inequality is just a greater than. There's no or equal to. So for this line, I'm going to draw a dashed line. Because again, I do not want the points on that line included in what we're calling a final answer. Now, it did go through the point 0, 0, so unfortunately I can't use that. I'll just use the point 1, 1. Again, any point anywhere other than the ones on the line are ones you can use. So if I say, let's test 1, 1, then going back up into my equation, 1 is greater than negative 2/3 times 1. So 1 is greater than negative 2/3. That is a true statement. A positive number being greater than a negative, definitely true. That means this test point 1, 1 is in the correct region. Right? That means we want to shade the region that 1, 1 came from. All right, let's take a look at these next two. We want to recognize these as a horizontal line, right? Y directly, compared to a number, y equals a number, would be a horizontal line located at y equals negative 3. And because of the or equal to, we will draw a solid line. Now again, you can pick a test point, but we also just want to understand that if we're saying the y values are less than negative 3, it makes sense that less than would be below. So there's our shaded region. Same with this one, x is greater than 2, so that's a vertical line located at 2, but without the or equal to, we know that's got to be a dashed line. And to be greater than 2, again thinking x-axis, greater than would be bigger, would be to the right. So we will shade to the right. But again, in both of these, you could have picked the point, test point 0, 0, found out it didn't work, and then shaded the other side for these specific examples. Okay, let's take a look at one example of a nonlinear inequality. So we definitely need to recognize this shape, recognize this equation or inequality. This is a circle. As a reminder, here was our general form for a circle, where h and k are your center and r is your radius. Now, this circle, notice there's no addition or subtraction inside of those squares. So this is going to have a center of 0, 0, and its radius, well, if r squared equals 9, then r would be the square root of that, so 3. So there's the two important characteristics about this circle initially. Centered 0, 0, radius of 3. Centered 0, 0, Radius of 3 just means look 3 in each of the cardinal directions, up, down, left, right. Those are your points in your circle. Now, as you draw it, do make sure we go back and say, because of this or equal to, is why this will be a solid circle. Or something close to a circle. Now, as far as shading, right? Again, think of this as this circle broke apart your entire plane into inside the circle and outside the circle. Pick a test point. If we test 0, 0 in that inequality, it'd be 0 squared plus 0 squared is less than or equal to 9. So 0 is less than or equal to 9, which is true. So we plugged in this point 0, 0. It came out true. This point is inside the circle. So the shaded region that represents that original inequality would be the region inside of the circle.